Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is Parity Checker. The topic is from the Combinational Logic Circuit. The subject name is Digital Electronics. So let us see what is a parity checker and then design an even parity checker. Let us implement the even parity checker. So, you know, for design or implementation of any combinational logic circuit, the three steps are truth table, K-map and logic diagram. These are the three steps. Okay, let us start the class. The three bits in the message together with the parity bit are transmitted to the destination where they are applied to the parity checker circuit. In the previous class we have seen at the transmitter we are having a parity generator, at the receiver side we are having a parity checker circuit to check if any error is there in the transmitted binary message. What is parity generator doing? Along with this binary message, it is generating one extra bit to make the number of bits either one even number of ones or odd number of ones depending on the even parity or odd parity generator. So, what is a parity bit? Parity bit is an extra bit added to the binary message. Why it is used? To check whether an error has occurred during the transmission of binary information. So, parity checker is at the receiver side, parity generator is at the transmitter side. The second point, the parity checker circuit checks for possible errors in the transmission. Third point, the output of the parity checker is denoted by PEC, parity and error check. PEC means parity error check. Fourth point, the information transmitted with even parity. The information transmitted with even parity, an error occurs during the transmission if the 4 bits received have an odd number of ones. Okay, the information is transmitted, till at the transmission side they have sent a even parity, but at the receiver side if they are receiving odd number of ones in the received information, it means an error has occurred, indicating that one bit has changed its value during transmission. Next point, PEC stands for parity error check. PEC will be the output of the parity checker. PEC will be equal to 1 if an error occurs, that is if the 4 bits received has an odd number of ones. So, let us now see. So, by these few points you might have understood the parity checker output is denoted by PEC and it is at the parity checker is at the receiver side to check whether the received information is having any error or not. Okay. So, here this is at the receiver side, this is a received message. So, we have written it as 4 bit received, this is a truth table, 4 bit received. 4 bit received means ABC is the binary message, along with this some parity bit is added. So, we have written it as ABCD. For 4 variables we will have total 16 combinations, that is from 00 to 111. So, how it is written? 0000, 0001, 0010, 0011, 0100, 0100, 0101, 0110, 0111, 1000, 1001, 1010, 11, 1010, 1011, 1100, 1101, 1110 and 4 ones. So, like this we have written total 16 combinations. Okay. Now, let us see what is our work now. We are designing a parity checker. What type of parity checker we are designing? An even parity checker. So let us take this condition when the message is comprising all 4 ones. 4 ones means, is it an even parity? Yes, it is an even number of ones are there in this message. So it is an even parity. So if it is even parity, error PEC will give 0. Okay, means there is no error. 0 means there is no error. Suppose if you take this message, it is comprising of 11110. This message is having 3 ones. It means odd number of ones, and we are having a even parity checker. So it's a odd number of ones means an error has occurred at least in 1 bit. So what we will do? The parity error checker will generate 1 indicating an error has occurred. In this message it is 1101, 3 ones, odd number of ones means an error is there. Error is there means it is indicated by high 1. Now in this message 1100, 1100 means even number of ones means no error. No error means 0. Okay, let us see this example. 1011, 3 ones. 3 ones means odd number of ones. Odd means an error has occurred, as it is an even parity checker. So odd number of ones, an error has occurred, so PEC will be 1. So in this way we can fill this PEC column and write the truth table. Let us see the first one. 4 zeros. 4 zeros means there is no error. So it is PEC 0. 0001, odd number of ones, an error is there. So it has generated 1. So when error is there, it is indicated by high value 1. If no error, 0, off. Okay. So likewise we have completed this truth table and observed that this PEC is having list of minterms where we are having ones. Suppose if you see this one, we are having one set 1, 2, 4, 7, 8, 11, 13 and 14. So I have listed the list of minterms here. We are having one set 1, 2, 4, 7, 8, 11, 13 and 14. As we are having 4 variables A, B, C, D, we will have a 4 variable K map A, B, C, D. We have written the outer structure 0, 0, 0, 1, 1, 1, 1, 0. CD 0, 0, 0, 1, 1, 0, 1, 1. How do we do the cell numbering? See, 0, 1, 2, 3, 4, 5, 6, 7. This is 8, 9, 10, 11, 12, 13, 14 and 15. Okay, after having the cell number, we can easily fill this ones here. So we are having it 1, 2, 4, 7, 8, 11, 13 and 14. So I written this. Okay. So after this one, we can easily write the terms. For this, what is the term? It is 0, 0, 0, 1 means 0001. 0001 means it is A bar, B bar, C bar, D. This one is 0010, that is A bar, B bar, C, D bar. For this term it is 0, 1, 00. 0, 1 means A bar, B, C bar, D bar. A bar, B, C bar, D bar. This term, now let us see this term. It is 0, 1 means A bar, B, C, D. A bar, B, C, D. Likewise for all 1, 2, 3, 4, 5, 6, 7, 8. 8 terms we have written. What will be the term for this one? It will be 1, 0, 1, 1. 1, 0, 1, 1 means A, B bar, C, D. A, B bar, C, D. So, we have written total 8 terms, and now we need to simplify it further in terms of XOR gate. Why we need to simplify is we need to draw this parity checker circuit using the XOR gates. Okay, let us solve the equation. We got the equation as A bar, B bar, C bar, D, all 8 terms we got it here. No? After getting this 8 terms, take A bar, B bar common. In these 2 terms, taking A bar, B bar common, okay. In these 2 terms, you are taking A bar, B bar, and then taking A bar, B common, then AB, then taking AB bar common. So, here we are getting it as, first term we have taken A bar, B bar common. So, here we are left with C bar D plus CD bar plus A bar B, C bar D bar plus CD plus AB, C bar D plus CD bar plus AB bar, C bar D bar plus CD, after taking the common terms. So, C bar D plus CD bar, this is an XOR gate. So, C XOR D, this is C bar D bar plus CD, this is XNOR. So, C XNOR D, this is C bar D plus CD bar XOR, C XOR D, C bar D bar plus CD, this is XNOR, C XNOR D. We got this equation, A bar B bar XNOR is written as complement of XOR, C XOR D of com bar. So, we have written this C XOR D, C XOR D bar, C XOR D, C XOR D bar. Okay, up to here it is clear. Now, let us take C XOR D common. So, in the first and third term C XOR D is common. We are getting A bar B plus AB. C XOR D bar common. We are getting A bar B plus AB bar. Okay. So, what is A bar B bar plus AB? This is A XNOR B. A XNOR B dot C XOR D plus A bar B plus AB bar. It is a XOR gate. A XOR B dot C XOR D the whole bar. Okay. So, we got this expression in terms of XOR. So, now this XNOR can be written in terms of XOR. So, what is this written as? A XOR B whole bar dot C XOR D plus A XOR B dot C XOR D. Okay, now let us take this A XOR B as X and C XOR D as Y. So, what we can get here? A XOR B is X. X means X bar. C XOR D is Y. So, X bar Y plus X Y bar. So, this is X bar Y plus X Y bar means X XOR of Y. What is X? X is A XOR B and Y is C XOR D. So, what we are getting? This complete equation as, we are getting it as A XOR B XOR of C XOR of D. This is a parity, even parity checker equation. So, how can we draw this now? A XOR B, how we can get it? Give A and B to an XOR gate. We will get A XOR B. We will get here A XOR B. By giving the input C and D, we are getting C XOR D. So, here both the outputs are coming to this input of XOR. We will get A XOR B XOR of C XOR of D. This is the even parity checker logic diagram. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.